This is CS1101 Lecture 11.3. We're going to continue our discussion of objects. We're going to start by talking about the toString method. Then we're going to talk about constructors and overloading constructors, so having multiple constructors that accept different parameters. But first, for a quick review, we define a class when we code a class file in Java, right? And that file must have the same name as our class name. We can declare variables of that new type, which will create an object or an instance of the class. So in a program, we can say we want a variable of the type whatever our class name is. So in our previous lecture, we made the class student, so we could create student variables and student objects. And these objects were instances of the class student. The class can define fields. So inside of this class, we can have fields and methods. A lot of times, fields will be referred to as instance variables, and methods should be referred to as instance methods. And instance methods, remember, differ from the typical methods we've made thus far in this class because they no longer use the static keyword. In client programs, when we declare a variable of this class type, we would say we are instantiating an object. So we are creating an instance of the object. That's called instantiation. This instance of the object contains its own copy of any instance fields and instance methods which are a part of this class. When a method is called by using the dot notation on a specific instance of an object, that instance becomes the implicit parameter for the method. So in our previous lecture, we used the student class, as I said, and we had students S1 and S2. And we wanted to write some information about students. And so we made a write method, a write instance method in the class, and we could call s1.write. And this method would write the name, which was stored in the instance variable name, and the GPA, which was stored in the instance variable GPA. And even though we had two different student variables, we had S1 and S2, when we called the method write, the student object instance, which we used with the dot notation, became the implicit parameter to the method. So it knew to get the information relevant for S1 if we said S1.write. Our instance methods that we write into the class fall in two varieties. First, there are accessor methods, which are going to return some information about the instance. So an example of this would be the get methods that we made for our student class. So the get GPA method returned the current GPA. The get name method returned the name. These are accessor methods. IsOnARoll is an accessor method. So it accesses information and returns true or false based on the information stored in the student instance. And accessor methods typically have non-void return types, which makes sense because we are wanting to get information. We are accessing the information stored in the object. So the return type shouldn't be void, otherwise we wouldn't be able to return anything to the caller. The other variety of instance method is mutator. So we have accessors that are going to access information and feed that back to the caller. And then we have mutators, which are going to mutate or change the object. So our set methods, set GPA and set name, would be mutators because they don't return anything. They're not accessing information, but they are changing the object. They're mutating the object. Therefore, these are mutators. Typically, mutators will have a return type of void because we don't want to get any information back. We are wanting to change the state of the object. So we've reviewed the accessor and mutator methods. It's important to remind here that for each instance variable, we should have an accessor and a mutator. So we have this instance variable called GPA. To encapsulate GPA so that we don't have to allow a user of this class to have direct access to the instance variable GPA, it's better to code accessor or mutator and accessor methods. So set GPA would be a mutator, while get GPA is an accessor method. And we'll do this because we want to set the instance variable GPA to private so that no one can directly access the variable. And we discussed at length why we would want to do that in the previous lecture, but remember the analogy with the ATM, right? Remember the problems associated with directly adjusting the current balance of your bank account? We could just go in and type in $10 million and then suddenly you have $10 million. So ATMs don't allow you to have direct access to these instance variables. Instead, they give you access to instance methods like deposit and withdraw. So when you call, by call I mean push the button on the screen, deposit and then feed money into the machine, it counts it and then appropriately increments your account balance. And this way it is able to encapsulate the current account balance so that you don't have the option to directly affect it and make potentially illegal changes. We could also talk about encapsulation and the need for it with the GPA. What if someone directly accessing GPA went in and typed in that you had a 100.4 GPA? Well, that's not a valid GPA. So in our mutator method, we could easily put some validation logic to make sure that the new GPA value that is passed to this instance method is a valid GPA before we assign it to the instance variable GPA. So the purpose for encapsulating instance variables is twofold. First of all, using set GPA and get GPA is simply more readable than just spurious modifications and reads from the instance variable GPA. So this increases the readability of the code. That's the first reason that we would use this approach to programming. The second reason is it provides a level of integrity to your instance variable data. By not allowing users to directly access those values, we're able to maintain the integrity of the value itself. So again, think of the account balance of the GPA. If we have to use set methods that we've created to access and modify these values stored in instance variables, then users don't have the ability to make illegal modifications. So we want to get some extra hands-on experience writing these class files that we then use in client files. So let's write another class called SongBase. And this SongBase class is going to have two instance variables. First of all, the song title and then the song artist. Both will be strings. And for each of these instance variables, we are going to have to include accessor and mutator methods because we want to encapsulate these strings. We want to encapsulate the title and the artist. SongBase class. Remember, we've already created the module file, so we go into the source file inside our module, and we're going to insert a new Java class, and we're going to call it uppercase SongBase. Uppercase because we are making a class file, so we name our classes with uppercase letters at the beginning of the initial word, and then camel case following. So here's our SongBase class. We said we want instance variables for the song title. So private string. Private is going to prevent anyone from accessing title directly. outside of this class. And private artist. So both of these are going to be inaccessible from outside the class. But we will be able to access them inside the class. Further, we said we want to have accessor and mutator methods for each of the instance variables, which is typical for each instance variable. We need to have some way of changing the value, most likely. So we'll have accessor and mutator methods. That way that our title and artist are fully encapsulated. So our method will be public. We'll do the title first. So public, we don't say static because this is an instance method, right? So we say public, and this is a mutator, so void set, and IntelliJ is guessing because it knows that typically you have an accessor and mutator for each instance variable. So it says, oh, I bet you're going to want to have a set title. Well, you're right. You do want a set title. And we'll pass a parameter, which is a string, and we'll call it new title. Typing is hard sometimes. And then inside this mutator, we're not going to do any sort of validation. Rather, we're simply going to set title equal to new title. So now we have our mutator method for title. Now we need our accessor method. So public, we're not going to say static because this is an instance method. We are going to have a return value though. We're going to return string because we're going to return the title. This method is called getTitle. We don't need a parameter, and we simply return title. So we'll speed up. Public void set artist string new artist. Public string return type get artist, no parameter, return artist. There we go. So we've implemented our song-based class. Let's quickly write a simple client. Well, we'll compile this first. Let's compile it. Recompile song-based.java. Parsing complete. We're done. Okay, now let's create a simple class to access it, and we'll call it client. We're going to need a main for our client to be able to run the class file. So notice in our classes that we intend to instantiate as objects, we don't have a main function. We don't have a main method. But in our client, which is going to be executable, we will have a main. So our executable program has a main, but our non-executable class file that we use to instantiate an object does not have a main. So public static void main string args. Okay, now let's create an object of type songbase. Songbase, we'll call it song1. We'll say equals new songbase. Then we will call our set methods, set artist, and we'll use ode. Oh wait, this is the artist. So we'll go with Nickel Creek. And we will set the title to Ode to a Butterfly. Real song, real band. If you've never listened to them, you should. Then we will do a print to show that we have successfully stored the information and retrieved it using our accessor and mutator methods. So song1 dot get title. So we'll print the title of the song, and then the string is by, and then so we'll concatenate the title of the song with the string is by, and then we will print out the artist, get artist. So make sure you understand what's happening here. We are using our accessor method to get the title, concatenating the returned string with is by, let's put a space there, and then using the accessor method for the artist instance variable to return the string which contains the artist. So let's run this. Ode to a Butterfly is by Nickel Creek. So we've shown this in the song-based class that we're making as an example, but remember the private modifier makes an instance variable inaccessible from outside the class definition. So inside it, all of our instance methods will be able to access this instance variable. However, outside, so in our client program, we will not be able to directly access to modify or read the value in the instance variable. We'll have to use our get and set methods, our accessor and mutator methods. As a note, remember at the beginning of each of our instance methods that we are using to get and set these values, we have the word public. So instance variables default to public if you don't define them as private. But we have defined our instance methods to be public so that they are available from outside of our class file. So if we did try to access one of these private instance variables inside of a client program, we would see something like this. Instance variable, in this case named X, has private access in, and then whatever class which X is defined in. So X has private access in point. So thus far we've been talking about review material from the previous 2 lectures, but now something new. So recall when we were trying to print arrays that we couldn't directly pass the reference variable which contained the array to the println statement. So if we said system.out.println and then created some array called myArray and passed myArray to the println statement as a parameter, we would just wind up with the reference or the address to our array printed out to the screen or to the console, right? So instead we had to use the arrays class. So we had to import java.util and then use the arrays class, which is built into that package or that library, and we were able to say arrays.toString and pass the array as the parameter to the arrays.toString method, and that would return the array as a string, and we could print out that string. Remember that something very similar happened when we were coding with arrays in an example program in a lecture where we used the array and used an instance method called toString. We said array.toString, and it returned a string that contained the address. So that's interesting. Passing the reference variable to the println statement directly results in printing out the address, and using array.toString prints out the address into a string. There's a reason those two do the same thing, and we're going to talk about that in just a moment. But first, we're going to talk about what happens when we use objects that are defined in a class. So an array is an object in Java, but we also have objects that are defined via some class file, like point, the point object or the point class. So if we created some point object like this and stored it in a reference variable p. And then we attempted to print out the contents of this point object using p colon space concatenated with the reference variable p. What we're going to wind up with is something like this: p colon space, and then the name of the class followed by the location of the object in memory. So that's exactly the same as what we saw when we were dealing with an array, right? It printed out the location of the array in memory, the array object in memory. So one way we could address this problem is by writing a print line statement in our client program, something like this: p colon space, open parentheses, dot x, so p dot x concatenated with comma, space, p dot y concatenated with close parentheses. And that would print something that was okay. That would work. But if we ever wanted to print another point, we would have to write this same print line statement again for that point. So we're winding up with a redundant and not reusable solution. Conceptually, printing out some object's contents to the console or generating a string for that object is something that everyone that uses the class is eventually going to want to do, most likely. So at some point or another, anyone who uses the point class is going to want to print the contents of that point to the console or generate a string which contains the contents. So wouldn't it make sense then to include a way to print out this point object or any object in general in the class itself? Remember, we said that a class should contain all of the relevant information for the object as well as any typical behaviors. I would say that printing out or generating a string which contains the contents of our object would be a typical behavior. So it would be much better if we simply could do something like this: system.out.println p colon space, and then concatenate that with p, and this would print out p followed by the location in xy coordinates. So remember, we said that when we were using arrays and we either use the toString method, so myArray.toString, not to be confused with the arrays class.toString, either using this myArray.toString or passing myArray to the println statement, either one would wind up printing out the address of the object in memory. The reason for that is because every class and every object in Java comes with a built-in toString method. And this toString method always prints out the name of the class and a reference to the hex location in memory. So like this. So the reason that when we called myArray.toString, we wound up with some memory location being returned in a string is because every object in Java comes with a built-in toString method. The reason that they all come with a built-in toString method is because the toString method is what tells Java how to convert an object to a string. So it's a prerequisite. Every object has to have a toString method, and if you don't define one, Java will give you one, and it'll give you the default toString method, and the default just returns the name of the class and the location of this object in memory. So if we don't want this to be printed out, we need to define our own toString method. And then, by defining our own toString method, we can use a println statement and pass our object as the parameter, and Java will know, oh, what you want me to do is use your toString method to generate a string to represent this object and print it to this print stream. So we would be able to override the built-in default toString method that just prints out the location in memory with a better toString method that prints out something helpful And then we would either be able to say print line statement and pass our object as a parameter, or if we wanted to, we could call the toString method directly. So we're going to be writing our own toString method to override or replace the default toString so that we have something more helpful. So in Java, when we replace a method with another method, which has exactly the same parameters and return type, so that's required. We can't say that we're overriding a method unless we have the same parameters and return type. But if we replace a method with another method with the same parameters and return type, it's called overriding. So if we want to override the default toString method, we have to have the exact same method name, return type, and parameters. Exactly. So it has to be called toString. It must accept no parameters because the default accepts no parameters, and it must return a string. And if these criteria are met, then we will have overridden the toString method. So if we were writing our own point class to create point objects, we might override the toString method in the following way. First, our method, this is an instance method that would be a part of the point class, so notice public but not static. The return type must be string because the default toString method has a return type of string. The name must be toString because that's the name of the default toString method. And then it must accept no parameters because the default toString method accepts no parameters. Then we define it to be returning a string which starts with a parentheses concatenated with the instance variable x, followed by comma, space, instance variable y, and terminating with a parentheses. So this would print out a typical XY pair. By overriding this toString method in this way, now we would be able to use a print line statement and pass simply our point object to the print line statement as a parameter, and it would know how to print it out in a much more helpful way, and it wouldn't simply print out the address in memory. So now we're going to go to our song-based class, and we're going to add a toString method, and this toString method should print out title colon title. So this will be the string title colon followed by a space, and then the value which is stored in the title instance variable. And then we'll put two spaces in between and print artist colon, and then the value stored in the artist instance variable. Let's modify our song-based class so that we print out the song appropriately when we use the toString method. But before we do that, let's show what happens if we just try to print out our object. So let's say system.out.println, and then our object song1. So we're just going to try to print it out. And we're going to put a string in there so that it makes a little more sense when it goes to the console. This is an attempt to print the object. And then in the second one, we're going to call the toString method. So remember, we have not written our own toString method. If we go look at our song base, there's no toString method defined here. But Java still allows us to call song1.toString because it gives us the default toString method, which is just going to return the location in memory and the name of the class. And that's the same thing that's going to be called when we pass the reference variable to the print line statement. So let's print this out to be able to see the results. Ode to a Butterflies by Nickel Creek. That's our fancy printed one that we handmade, but we can't reuse because it's not part of our class. And then here's where we called, or where we passed our object directly to the print line statement. This is an attempt to print the object, and it just printed out song base and the memory location. And then here's where we called song base, well, song1.toString. So when we called song1.toString, it printed out the exact same thing, because what happens when we pass song1 to the print line statement is Java understands what we really want is to use the toString method. And so Java uses the default toString method in this instance. Down here we explicitly call song1.toString, but in both cases the result is the same. So we can get rid of our preamble here momentarily, and we see that both of these yield the same thing. So both of these are using the toString method. So if we want to be able to print this out in a prettier way, when we pass song1 directly to the print line statement, we need to override our toString method. So let's go in song base and do just that. So it needs to be public. It's not static, it's an instance method. The return type has to be string, because remember, the return type, name, and parameter list must precisely match the method that we're overriding. So it has to return a string type, it has to be called toString, and it has to accept no parameters. And then what we're going to do is we're going to return the word artist, colon, space, and then concatenate this with the artist, concatenate that with 2 spaces, followed by title, colon, space, concatenate that with the value stored in the instance variable title. So now this will return this string when we call toString. It says we have an error. Let's look at this error. Ah, yes, no semicolon. Easy to make error. All right, let's recompile our class. Finished. Let's go back over here and we're going to run the exact same code. So where previously we wound up printing out the location in memory, now we should print out our new string that we just defined in our new toString method that overrides the default. So this is the print statement that we did from the previous lecture, or the previous example. And here is our printed out. This is an attempt to print the object artist Nickel Creek title ode to a butterfly. This is an attempt to directly call the toString method artist Nickel Creek title ode to a butterfly. So now we can easily print out our song1 object because we have overridden the toString method. So now we don't have to write our own print line statement and figure it out and redo that work each time we want to print a song and a title. We can simply use print line and pass the reference variable. So think back to our first example class. So we had the student class, and to make a student object, we would create the reference variable S1, and we would have to also create the student object in memory using the new and then the class name followed by open and close parentheses. Then remember we said that each of the instance variables was initialized to 0 or a 0-like value. So false if it was a boolean, or 0.0 if it was a double, or null if it contained a reference variable. So we would have to go through to set each of those instance variables and use our mutator method. So use the setName mutator method to set Snoopy, setAge mutator method to set the age to 7, and setGPA mutator method to set the GPA to 3.95. But it would have been a lot easier if we could just pass the values that we wanted to have in the name, age, and GPA when we created or instantiated the object in the first statement. This is how we did with scanner, if you remember. So to create a scanner that looked at the system.in, so a console scanner, right? We would just say scanner, open parentheses, and then pass system.in as the parameter to the constructor when we instantiated it. So it would be better if we could do something like that with our student class, where we have student S1 equals new student object with these parameters. And this would automatically fill the name, age, and GPA. So to make this a reality, what we need to do is use something called a constructor. So a constructor is a very special class method that is going to perform initializations when we create an object. So when any new object is created in some client file, so we're instantiating an object, the constructor is automatically called. So when we said student S1 equals new student, open and close parentheses with no parameters, we were calling the default constructor. And constructor calls always have this format. We have some class name and a reference variable of that type, and we assign it a new object of whatever the class name is, type, and we give whatever parameters we want to this class name. And what happens is Java will use the constructor which matches this parameter list. So then this constructor method that gets called when we create this object will perform any actions that are written into it, including but not limited to initializing any values. So there's a couple of important points about constructors that we need to make here. First, each constructor must have the same name as its class. And a constructor does not have a return type, not even void. So when you declare a constructor, you do not include a return type. And finally, we can have multiple constructors defined for a given class. However, each of the constructors must have a different number or different type of parameters. And we've talked about this before. This is called overloading. So we can create multiple constructors which will be given different sets of parameters, either a different number of parameters or different types of parameters. So this is a reminder about overloading. Remember, just as we've said, we can have two or more methods defined with the same name as long as the parameter list can be used to tell them apart. So when Java compiles, it uses the parameters that are passed to the method to tell which of these methods with the same name you're wanting to use. And this is called overloading. So Java is going to use either the number of arguments or the type of arguments, whichever it can use. So you could have a different number of arguments, a different number of parameters, or the same number of parameters, but a set of parameters with different types. Either way, the compiler is going to be able to tell the difference between the methods that you wish to call. If there's not an exact match, Java is going to attempt to automatically convert ints to floats and so forth. So it's going to automatically try to do type promotion to see if any of the available methods now match the promoted types of the parameters that are given. And if not, if there's still no match, then Java is going to throw an exception and say there's no method with these parameters. So here's an example of overloading. So we've talked about two different things in this lecture. One, overriding. So we wrote a toString method to override the default toString method. And when we were overriding, we had to have the same return type, the same method name, and the same set of parameters. But when we're overloading, which is what we're showing here in this example, we have different sets of parameters, either a different number or a different type. So we have the same name, but different sets of parameters. So as our first method here has two integers as the parameter list, it can be told from the second method called printAverage, which has 3 parameters. So when we call printAverage, Java can tell which of these two we want to use based on the number of parameters. This bottom version of printAverage uses 2 parameters, so Java couldn't use the number of parameters to tell it from the first printAverage method, but the type of parameters is double. So Java would be able to use the parameter types provided when you call the method to know which of these two you intended to use. Few more points on constructors. First of all, usually at least one of the available constructors will have an empty parameter list. This is called the default constructor. The default constructor is used when you want to create an object but you don't yet want to initialize the values in your instance variables for that instance of the object. And finally, if we do not define any constructor in our class, then Java automatically will create a default constructor with no parameters that will assign all instance variables 0 or 0-like values. So this is the same behavior from Java that we saw with the toString method. Java automatically gave us a default toString method, but it didn't have the functionality we wanted, so we had to override the toString method. Same thing here. Java automatically has given us a constructor, but we may not love the functionality of Java's default constructor, so we can override their default constructor with our own. And further, we can create multiple constructors and use this useful overloading concept so that we can have multiple constructors that accept multiple different parameter lists. And one helpful thing is that our methods, so our instance methods, which we have declared in our class, can be used in our constructor. So if we have some setGPA method in our student class, we can write a constructor for the student class, and inside that constructor we can call setGPA. So here would be a constructor, public, and then the class name, and then whatever parameter list, and then we can call the set, in this case for the student class setGPA, mutator to set the value of the instance variables to whatever we decide to set them to. Notice there's no return type. So it's not public void and then class name. It's public and then the name of the method is the class name. Also notice it's not public static class name. This method is not static, it is an instance method. It's just a very special instance method that is a constructor, so we don't have a return type. So how would we go about testing a constructor that we've written into a class? Well, what we would do is change our client program to instantiate objects and call each of the different constructors and then verify that they worked properly by printing out the object or the instance variables to the console. So as an example, what we would probably do is we would, in our client program, create a student reference variable called S1 and store the reference to a new student object in that variable, and we would pass as parameters to this constructor Snoopy, and 3.75. So we've only given the name and GPA. So this should populate name and GPA, but then the age should take on some default value. And then we would print out this student S1. And remember, we're now allowed to do system.out.println and pass the reference variable directly to the println statement if we have overridden the toString method. Otherwise, this would just print out the address. But in this way, we have used our constructor, and then we printed out the results of constructing this object. And we can check to see if it worked as we intended. So going back to our student class example, we would have these instance variables, name, age, and GPA, and then we could define a constructor like this. Public, and then the name of the class, so student, notice not static, not void, there's no return type, and we did not use the keyword static because this is an instance method. So public, and then the name of the class, and then whatever parameter list we intend to pass to this particular constructor. So in this constructor, we expect the initial name and the initial GPA. And then we're using our mutator methods, setName and setGPA, to set the instance variable to the initial name passed to the constructor and the initial age passed to the constructor. And now we could have more constructors which have different parameter lists. So perhaps we would want one where they could pass in the initial name, initial GPA, and initial age. Java would then be able to tell which of the constructors we intended to use based on the parameter list. So this would be overloading the constructor. So now let's go back to our song base class and write a constructor, a default constructor, that will initialize the title and artist to be empty strings. Right? Because the default constructor that Java has for our song base class, so the default constructor that it generates automatically, is going to assign our string objects for title and name the null pointer, right? So a string is an object, so when Java uses the default constructor, it assigns zero-like values to each of the instance variables. And when we're dealing with an object, a zero-like value would be null. So instead of assigning null to each of our instance variables, we want to override the default constructor and have our constructor initialize the title and artist to empty strings. And this is going to be the constructor with no parameters passed at all. Then we're going to further overload the constructor. So we're going to add another constructor that has the same name, and we're going to have a different parameter list so Java can tell them apart. And in this one, we're going to accept as a parameter a string for the song title and a string for the artist, and automatically set or initialize the variables accordingly. And as a tip, when you do this, use the existing instance methods to help do the work. So rather than having to write the statement to actually set the title, use the mutator method. It's much cleaner, more readable, and if for some reason in the future you decide that you want to add some validation logic to what a valid title or valid name would be before you actually assign the value to the instance variable, then you don't have to go back and code that also into your constructor, because it's using the same mutator method that users would typically use to set the song title or song artist. Constructor to our song base class. First of all, we said we wanted to add a default constructor and then add a constructor that had a parameter set. So our default constructor is going to have the keyword public, because it's going to be available outside this method. But then we will not use static, because this is going to be an instance method, and we will not give it a return type, not even void. So it has to have the exact same name as the class name, song base. And we're going to give it no parameters because this is our default constructor. And we want to initialize title and artist to be empty strings. Title equals empty string. Artist equals empty string. Next, we want to create another constructor. So we're going to overload this constructor method. So when we overload something, it has the same name, but a different parameter list. See, so right here, this says this is not okay. Already defined. Already defined, or is never used. So here it says already defined, and here it says never used. So this is bad. We need to give this some parameters so it understands this is a different constructor. So first of all, parameter 1, init title. Parameter 2, init artist. So now, notice our red underlining is gone because our IDE understands that this is not the same method. This is an overloaded method. So we can set our title to be equal to our initial title that is passed in as a parameter, and set our artist to be the init artist that was passed in as a parameter. So there we have it. So when we are dealing with constructors, typically we'll have a default constructor that has no parameters, and then we can overload it with other constructors that have the same name but different parameter lists, either different because they have different types or a different number of parameters. Now, don't get confused between overloading and overriding. We're overriding the toString method. Here, we are overriding the default constructor, but here we are overloading the constructor we've already written with a second constructor that has a different parameter set. Now, let's test it. So rather than having to set these after creating the object, we will set them, so we said it went title then artist. So title, artist. And now we won't have to use our mutator methods after calling or after constructing the object. But wait, we said it would be better to use our set methods instead of directly accessing the instance variables. So let's, instead of doing this, let's use our set title, and we'll set it to an empty string. And we'll use set artist to set this to an empty string as well. So this is a further improvement. So now any changes that we make in our set title or set artist methods will also be reflected when it's called from the song base constructor. So then in here we'll do the same thing, set title, and we're going to pass it init title. Set artist, we'll pass it the init artist. So this is a big improvement over what we were doing in the previous iteration where we were directly accessing our instance variables. So now, as we were saying, our song base constructor is called when we create this new object, and then we will print this new object out. Then we're going to create an empty song, so song base, and we'll call this reference variable empty song, and we will create a new object, And this time we're going to call our default constructor, so no parameters. And then we'll print out this empty song. So now let's run this code. So first of all, let's talk through it. So we're creating this song1 reference variable, storing a song base object in it based on the song base class. And we're using the song base constructor that has toString parameters. And then printing out song base based on the overridden toString method that we have in our song base class. Here we are doing the precisely same thing, except we're using the constructor that has no parameters. So it's our default constructor. And then we're again utilizing the overridden toString method that we defined in our song base class to print out the contents of this song base instance. So this empty song contains an instance of the class song base. Song1 contains an instance of the class song base. So here we go. Let's run the code. Before we run the code, we corrected an error. We had song1 typed in here, and the second error was, notice this is supposed to be init title, and this is supposed to be init artist. Nickel Creek is the artist, and Ode to a Butterfly is the title. Order matters, right, when you're passing parameters, so they have to pass in the order you intend to receive them. So now let's run this code. So now in our output we see artist Nickel Creek and title Ode to a Butterfly for the song1 contents, which was initialized using our 2-parameter constructor, and using the default constructor with no parameters, we see that it contains only an empty string for artist and title. So remember, there's some common bugs that you'll probably run into. At some point you'll probably forget and include a return type on your constructor method. This is going to cause problems. Don't do that. Another common error that most likely will occur at some point when you're writing instance methods is you're going to wind up intending to write to an instance variable called x, and you're instead going to accidentally declare a local variable called x. So in Java, you can declare a local variable with the same name as an instance variable. And when this happens, Java assumes you want to use the local variable, not the instance variable. So this will create a new local variable, and it won't write to the instance variable. So you need to be aware, don't put int or some data type before the instance variable when you use it in any of your instance methods. At this point, we're going to introduce the keyword this. So this keyword, so this as a keyword, is a way to refer to the implicit parameter. So recall, the implicit parameter is the object that you use to call some instance method. So for a student object called S1, and to use some instance method called get GPA, when you say s1.getGPA, s1 is the implicit parameter. So inside of our instance methods, we can use the this keyword to refer explicitly to the implicit parameter. Usually we would use this to increase readability. So in situations where you want to refer to an instance variable, we can use the name of the instance variable in the class, or we could say this dot instance variable. And we'll look at that further in a moment. Sometimes that greatly helps with readability, where you might have other variables similarly named in a local scope also in that same method. You could also use it when calling another instance method. So you could say this. So if we were in the getGPA method, you could say this dot getName if for some reason you needed to access the name in the getGPA method. Or if you were going to pass yourself as an argument. So as an example, if you were going to call some function that accepts a student object as a parameter, you may be able to call that method and pass this as the parameter, which is a way of passing the implicit parameter, which is the object, to this other method. Finally, typically you'll see it used whenever you want to call another constructor from inside of another constructor. So we can have multiple constructors defined for a given class. So if we want to make use of the functionality inside of constructor A from the interior of constructor B, we could use the this keyword to refer to the implicit parameter and access the constructor method A. So I'm sure that's a little bit confusing, but let's look at some examples, and I have no doubt it will become more clear. So now let's look at a specific example where we are going to refer to an instance variable using the this keyword. So remember, it's illegal to have two variables of the same name in the same scope. So there are exceptions to that rule, specifically when the scopes are overlapping. So it would be an error if inside of a program we declared a variable called age of type int, so it was a local variable to this method, and then inside that same method later on we declared another local variable called age. Java would throw an exception and say, this is an error, you can't have multiple declarations of the variable age in this scope. However, we can have an instance variable which exists at the class scope and a parameter declared for a method which will exist in the scope of this method. And Java will be okay with this. This is no problem. But which one are we going to refer to then? So inside this method, if we say age equals age, which age are we referring to? Well, this is called shadowing. And what's occurring when we do this is Java has a preference order. So it will assume we're referring to the most specific scope. So the instance variable is at a more general scope. It exists at the class level scope. Whereas age only exists in this method, setAge. So Java will assume that we are referring to the most specific age. So the most specifically scoped age. So what will actually happen here is we will be assigning the value stored in the parameter age to the parameter age. So make a mental note of that. If you have two variables with overlapping scope and the same name, Java is going to assume whichever one has the narrowest scope. So in this case, the one that is declared in the scope of the method has a more limited scope than the one which is declared at the class scope. So our instance variable is overshadowed by our method parameter. So if we just use the name age, we're always going to be referring to the parameter inside this method. But maybe we want to have a parameter named age even though we have an instance variable called age. There are legitimate reasons why we'd want to do that. So far we've been sort of negotiating around that problem by using names like new age or my age, right? So instead of using the parameter name age for this method, we've been saying things like new age. But it might be better to actually use the name age. So how could we go about this where we have two variables in the same overlapping scope with the same name and be clear and be able to actually access our instance variable? To do this, we want to use the this keyword. So with a simple modification to the previous code, we can, instead of referring to the parameter refer to the instance variable. So by using the this keyword, we're explicitly telling Java we want to access the instance variable that's a part of this implicit object. Remember, so we said if we called s1.setAge, s1 is the implicit parameter. So we're saying explicitly here, we want to access the instance variable that's a part of the s1 object. So this way we can have an instance variable called age and a parameter called age, and then inside the setAge method we can store parameter age inside the instance variable age. So just as we access the instance variables by referring explicitly to the implicit parameter using the this keyword, we can also call instance methods using this keyword. So we have some toString method which is going to build the string that should be returned anytime we attempt to pass this object to a print stream, or anytime the toString method is called, and we want to create some method called write. So inside of write, we are passing in the parameter p, which is a print stream, and we want to call p.print, and we want to pass the string as the parameter to the print method, which is generated by the toString method. You see, so we want this same string that we generate using the toString method to be passed to this p.print method when we call write. So rather than copying this code, which would be redundant, and redundancy is bad, instead we can say p.print, and then as the parameter we can actually call the toString method from inside of the write method. And we do this using the this keyword. So this refers to the implicit parameter dot toString. So this calls the instance method toString that is a part of the implicit parameters object. So finally, we're going to modify our song-based class to use the this keyword anytime we are referring to instance variables or instance methods inside of the class. So let's start with our constructor. So this refers to the implicit parameter. Now, instead of saying new title, we're going to change this to title. And notice this is okay, but if we allow this to stay, then we're not going to be writing the parameter title to the instance variable title. Rather, we're going to, in both of these uses, be referring to the parameter. So to tell Java, hey, we want to look at the instance variable instead of this parameter, we have to use the this keyword. We'll do the same thing with returning title. We'll change this new artist into just artist. And then we will add the this keyword so that Java knows we're referring to the instance variable. Use this to refer to the instance variable. Now here, instead of directly accessing these instance variables, we're going to say this dot get artist. And here we're going to say this dot get title. So we're going to use our accessor methods in our toString object, or in our toString overriding method. So now let's recompile our song-based class. There we go. And now we're going to run it. Should be nothing changed. Functionality should remain, but the code is now more readable. So let's look at this and see why. Well, as I'm reading down through here, we have these instance variables, title and artist. Then we have our constructors, song base and song base. The first constructor is going to set the title to an empty string and then set the artist to an empty string. See, even without comments, I can read this and understand what it does. In our second constructor, we're setting the title to the initial title that was passed in as a parameter. Then we're setting the artist to the initial artist that we passed in as a parameter. In set title, we are taking the parameter title and setting the instance variable, which is a part of the implicit object's instance memory, to the parameter title. We're doing the same thing with get title in reverse. When get title is called, we return this object's instance variable called title. So we're removing ambiguity and increasing maintainability because the readability is increased.